This is a question of a brake. So the car has an initial velocity. Remember that we have this very powerful equation, and if you are going to have a full stop, it means your final velocity is going to be 0. The time is given, and this is given, so you can find the average acceleration. In number 7, you have again a graph of velocity versus time. So the distance you can find between the area between those two times, and the acceleration, these are just the slope, because the slope of the velocity versus time is given by, when you have velocity versus time, the slope is the acceleration. This is a car that is speeding up and it has an instantaneous velocity at a particular time. So these will be again something of this thing nature, and so the change in velocity is always the acceleration times the change in time. So you have the change in time and you have the acceleration, then you are supposed to have the change in the velocity. And then to read the velocity at a particular time, you probably just can do it from here. This is free fall, and in free fall, when an object starts from a certain distance, from a certain distant age, if it starts with 0 velocity, then the distance travel is 1.5 gt squared. So from there you can calculate the time, and of course you can also calculate the distance for twice the time there. This is a question of there are 2 times involved here, the time to fall. So that time, according to the equation above, is the height divided by g square root, plus the time that the sound takes to go up. The time that the sound takes to go up is the distance that it has to travel to get back to the ear divided by the velocity of the sound. Number 11, this is again a problem of these equations with constant acceleration. So if you have a cheetah that can accelerate from rest, so and you want to know what is the acceleration in this amount of time, then since it started from rest, this is the time, this is the speed that it achieved, then you can get the acceleration. Once you know the acceleration, then you can certainly know the distance and actually answer the other questions. And finally, this is a question of average velocities. And so she has to run 1,000 meters in 4 meters per second. So the total time, it has to be the average speed, which is 4 meters per second, is equal to the total displacement, which is 1,000 meters divided by the total time. So the total time is 1,000 divided by 4, which is 250 seconds. Now you know the time that it took in this first, because they give you the average speed and the distance, so you know that time. And what is going to be the average speed here, you calculate it because you know the time that it needs to take here in order for the total time to be 250.